What if I told you that you can solve some SAT math questions in the space of 10 to 15 seconds using the Desmos Graphing Calculator? In this video, I have 10 algebra questions that we are going to look at together using Desmos Graphing Calculator. Welcome to BMax. Let's go. Look at the first question. 3 brackets 2x minus 6 close brackets minus 11 is equals to 4 brackets x minus 3 plus 6. This is an equation of two linear equations in one variable. So let's look at how I'm going to solve it on Desmos. So I will type the first equation on the left as y equals to 3 brackets 2x minus 6 close the bracket minus 11. Then I will type the second equation as y equals to one on the right, 4 brackets x minus 3 close the bracket plus 6. You can see that this green represents the first equation, 3 brackets this green line represents the first question because they are both linear graphs, so it's going to be a straight line graph. While this blue represents the equation 2, the blue line represents equation 2. You can see that they actually intersect at 11.5, 40. So this 11.5 is the x value, y 40 is the y value. So I can say that my x is actually equals to 11.5. But you are asked to find what? 11.5 minus 3. You have to find x minus 3, which is 11.5 minus 3. So let's type in that. Let's type what is actually 11.5 minus 3. That is 8.5. So 8.5 should be 17 over 2. So this is our answer for A. So let's move on to the next question. The next question, this is a case of two rational polynomial. And the first one I saw was a case of two linear equation. So this is a case of two rational polynomial. So the same thing, I'll use the same idea. I'll type the left hand side as y equals to 2. Okay, and this is a fraction, so I will look at my other button here. I press divide. This divide over. So I have 2 open brackets x plus 1 close the bracket. I click on the cursor at the denominator. So I have x plus 5. So that's my equation on the left. Then on the right, I have y equals to 1 minus the same idea. I click on this divide. They give me a fraction, numerator and denominator. So I have 1 divided by x plus 5. Okay, let me zoom it for you so that I can actually see where they intersects. Let me zoom it for you. So you can, this is the graph. This is actually the graph. They actually intersect at let me zoom it for you so that I can see. You can see this is the graph. So they actually meet at this point. They meet at 2, 0 points. The x coordinate is 2, the y coordinate is that. So that is all right. So let's go to question number 3. Question number 3 is actually a question on linear function. You can see the 2 points, 2,5 and the 4,11. So you have to find the equation. Instead of you solving it the normal conventional way of using y equals to mx plus c, sorry, mx plus c, and you have to get your m using the formula y2 minus y1 over x2 minus x1, using your m as, that means your y2 is actually be 11 minus 5 over 4 minus 2, getting your answer. Then there are easier way of solving this. And after getting your m, I think this should be 6 over 2. Your m should be 3, and you are able to have y equals to 3x plus c. So you're using, let's say at 2,5, that's like 5. That's like 5 equals to 3 bracket 2 plus 6. 5 equals to 6 plus c. So c equals to minus 1. So instead of you solving like this, and at the end you get your y equals to 3x minus 1. This is a whole lot of waste of time. You can solve this on Desmos using the click on this plus. You see where we have table. So slot in the table 2 and 5. The second point is 4 and 11. Then you click on this regression. You can see my answer. My answer is 3x minus 1. 3x minus 1. That is option C. So instead of you solving it, the way of solving it, that will take a whole lot of time. You can just use your Desmos calculator and you get your answer. Let's move on to the next question. Question number 4. In the xy plane, line K has slope of 5, that's m equals to 5, and y-intercepts. No, you forget that if you have y equals to mx plus c, this c is called the y-intercept. So I can see my c is minus 35. You know, on the y-intercept, s is 0. So this is my c. So this one will be y equals to 5x minus 35. So let me type this equation in Desmos. What I have to find, I have to find the x-intercept, the x-coordinate of the intercept. So let's type this question in Desmos. Y equals to 5x minus 35. So you have to find the x-intercept. So this is my x-intercept. My x-intercept is actually 7. You can see our x-intercept is actually 7. So that's my x-intercept. So my x-intercept here is 7. So the answer here is 7. So you can see it here. You can see it here. So x-intercept 7. Okay, so let's move on to the next question. Now, if you have something like this, we're told that the table give 2 points x, y, k 13, k plus 7 minus 5. The table gives the coordinate of 2 points in the plane. Now, look at this statement here. The y-intercept is given by k minus 5 comma b. Now, take note on the y-intercept. For y-intercept, take note. For y-intercept, your x equals to 0. On the y-intercept, our x equals to 0. So, this point is the same thing as saying x is 0 and y. So I have a value for, I have a value for y, and now x is 0. So I can compare this. I can equate my k minus 5 to be 0. So from there, k equals to 5. So if k equals to 5, I can change this table. This table will now change to something like this: x, y. So here I have k, so I have 5, 13, So I have k plus 7. That'll be 5 plus 7, that's 12. And is minus 15. So let me punch this on the Desmos calculator. So the same idea, click on plus, you see table. So I have 5 and 13. I have 12 and minus 15. So, okay, let's look at the graph. Let's zoom it out. Okay, so we add the regression. So this is the graph. So what I have to find, you have to find B. That B is the y-intercept. So our y-intercept is actually this. So this is my y-intercept. So if I click on the y-intercept, it will give me this. So my y-intercept is actually is 0.33. So our answer here is 33. So so more like is 0.33. So our B is 33. If you look at the graph here, I can zoom it out for you so that you can see it clearly. Let me zoom it out for you so that you can see what is going on there. So uh, we have uh, we have this, so you can see what's going on there. So this is our answer. So that's okay. So let's move on. Let's move on. Okay. All right. So let's go to the next question. Question 6. This question says that if f of x equals to 3x minus 4 minus 5, a graph of the line is translated 4 units to the right. This is a question on uh, transformation of function. Transformation of function. Transformation of function. Now, we have two types there. We have horizontal transformation and vertical transformation. And we have horizontal translation and vertical translation. We have some other types, the stretch, the compress, and co. But let me just focus on these two now. So let me focus on the horizontal translation. Let me call this the HI, the HT. Let me call this the VT. For the HI is divided into two. Number one, we have the right movement, and number two, we have the left movement. So let the function be equal to f of x. So if a function is translated to the right by a unit, if a function of translated to the right by a unit, so what I have is f of x minus a. If a function is translated to the left by a unit, what I have is f of x plus a. Please take note of that. So the a is number of times it was moved. So that means I can either move the graph to the right or to the left. That's horizontal. Or I move the graph to the up, or I move the graph down. That's what translation. So in this question, we were told that the graph was translated by 4 units to the right. So that means that that means f of s is 3x minus 4. And to translate to the right by 4 units actually means, this actually means f of x minus 4. So this is what I'm looking for. I'm looking for f of x minus 4. So how do you use Desmos to do this? So I just type the something on Desmos. I look at my expression f of x. After my expression f of x f of x is equals to my fraction. My fraction is 3x over 4. 3x over 4, then minus 5. So this is my normal f of x. So what am I looking for now? I'm looking for, it has been translated by 4 units to the right. So that means I'm actually looking for f of x minus 4. That's like that. So what's my f of x minus 4? So f of x minus 4 is equals to, let's see. So I'm looking for f of x minus 4. So let's see how does that pans out. How does that pans out? Let's see. So I'm looking for f of x minus 4. So when I'm looking for f of x minus 4, I'm looking for the coordinate of the y-intercept. So the y-intercept is actually what? Is 0 minus 8. So when I have a graph of f of x minus 4, this is the graph. If I have a graph of f of 3x minus 5, this is the intercept is minus 5. So if I now have this second graph now, the intercept is minus 8. So my answer here is minus 8. So the answer here is actually minus 8. So that's the idea. So think of it like this. That is actually s equals to 4. That's to the right. That is your 4 is on the right. X axis. So if you have s equals to 4, so that will be x minus 4. So that's why you have function of x minus 4. So that's what is going on there. So this is what is called the horizontal translation. Let's go to the next example. The next example. Look at this question here. Look at the question here. The question says that we have, this is talking about vertical translation. Yeah, vertical translation down to 5 minutes. So what you do here is that let me really explain vertical translation. Vertical translation. I explained horizontal translation in the last example. Vertical translation. Now the graph can go up or it can go down. So let's say the graph is actually y equals f of x. So if the graph is going up by a unit, your new graph will be y equals to, let me use h. Your new graph will be h equals to f of x plus a. If it's going up by a unit. If it's going down by a unit, the new graph will be, let me use g. G equals to f of x minus a. So that is going down. So going down is f of x minus a, while going up is f of x plus a. So, but in this question, there's no f of x. So let's get our function. Let's get our f of x. So let's use Desmos to get our f of x for this question. That's the actual. They only give us the points x, y, x, y. So let's get the actual f of x. So let me use my Desmos. I'll type in table 18 and 130, 23 and 160, then 26 and 178. So let's check the regression. Now, see the linear regression, our f of x is actually 6x plus 22. So if f of x is 6x plus 22, they said the graph has moved down by what? Has moved down by 5 units. So move down by 5 units, so it is something like this. So I'm looking for, let me call the new function now, g of x. So g of x will what? F of x minus 5. Okay, so let's do something here now. So let's type our f of x as, our f of x is, 6x plus 22, 6x plus 22. Then let's type our g of x. G of x is, our new function g of x is now f of x minus 5. So this is my g of x. That's the red. You can see this is the red. This is the red graph. My f of x is the blue graph. The y-intercept for the blue graph is, you can see 22. Is 0.22. While the y-intercept for the red graph, the red line, is actually 17. So we're actually looking for the, um okay, we are looking for the x-intercept of the line k. So what's the x-intercept now? Our x-intercept is actually minus 2.83. So our x-intercept is actually minus 2.83. Look at it, x-intercept. Where it meets the x-axis. This is where it meets the y-axis. So let's reduce the graph. Let's zoom it out. Okay. So this for the so this is the x. See, this is the graph actually. The red is for the graph. This for the second graph. Why this one for the first graph? So you can see it. So the x-intercept for the second graph, which is the red line, is actually what? Minus 2.83. So that is minus 2.83. So which of the options is minus 2.83? Let's see. Minus 2.83. Let's check. Minus 26 over 3 if they give us 2.83. No, that's one. Let's check minus 9.2. That's obviously wrong. That's minus 4.5. Let's check minus 11. Let's check my option C, minus 11 over 3. Yes, that's actually wrong too. Then that will be D. Let's check option D. That's minus 17 over 6. So minus 2.83. So that's option D. We are looking for the x-intercept. So that's my answer for D. Okay. Let's look at the next question. Let me clean my Desmos here. Okay. Let me wipe out all of this. All right. So the next question says that if the graph 27x plus 3y equals to 297 is shifted down 5 units in the xy plane, what is the y-intercept? So this is a case of vertical translation, but the one going down. So I think I've explained that before. If you have vertical translation going down, your new function will be y equals to f of x minus a. That is the unit by which it's going down. So here, let's get our f of x. Let's make y the square formula from here. If we have 27x plus 3y equals to 297. So if that would be 33y equals to minus 27x plus 297. So our y is actually minus 27x plus 297 divided by 33. So I can call this my f of x. This is my f of x. What I'm looking for is what? I'm looking for the new function. Let's call that h of x. So h of x is actually f of x. It said it has moved down by 5 units. Moved down by 5 units. So f of x minus 5. So what I will do is that I will look at my Desmos calculator. I will type function. I will type my function. Let me type my function. f of x is equals to, let me type my function. So f of x is actually minus 27x minus 27x plus 297 divided by 33. So that has a y-intercept of 9. Okay. So when it has moved down by 5 units, so let's call that one h of x. So h of x is actually f of x minus 5. Can see h of x is a dark black, is a black graph, black line, whatever you can call it. So what is the intercept for that? The intercept for that is 4. So what you are looking for is what is the y-intercept of the new graph or the resulting graph, which is this. It's actually 4. So our answer here is the y-intercept here is 4. So that's how you go about that. Okay. Okay, let's move to the next question. Look at this question. This question is a question on systems of linear equation that says if w open a bracket minus 3x plus x. So if you have something like this, for system of linear equation we have 3 types. We have one solution, we have no solution, and then we have infinitely many solutions. Infinitely many solutions. I have a video on this. You can check my channel for a video on this. So if ax plus b is equals to, let's say this is b, is equals to bx plus q, it will be no solution if the coefficient of x are equal. That is, if a equals to p, and if they are constants, if b is not equal to q. So what I will do here is that it will be no solution if a equals to p. It will be one solution if it will be one solution if a is not equals to p and b is not equals to q. Then it will be infinitely many. This one is for one solution. It will be infinitely many if a equals to p and b equals to q. That means the coefficient of x are the same and the constant are also the same. So that's infinitely many. So let's quickly solve this question now. So what I'll do in this question is that I will expand this. So if I expand this, I will have minus 3x minus 3wx minus 3wx minus w plus x is equals to 10x minus 5. So if I calculate like terms, minus 3wx plus x minus w is equals to 10x minus 5. So if I factorize here, I will have if I factorize here, we have x bracket minus 3w plus 1 minus w is equals to 10x minus 5. So I equate the coefficient of x. The coefficient of x in this case is minus 3w plus 1 equals to 10. The coefficient of x here is 10. The coefficient of x here is minus 3w plus 1. So if I solve this, um, if you solve this, if you solve this, I should have minus 3w is equals to 9, and our w equals to minus 3. So in this case, I feel solving directly is faster here. But if they say find the value of w for which solution has no solution, so our answer is actually minus 3. But let's see if we can use Desmos to solve the kind of question. So let's use Desmos calculator to solve this question. So I will type the left hand side as equation 1. So y is equals to w, open the brackets, minus 3x minus 1, close the brackets, plus x. So it said add a slicer. I'm going to explain that. Uh, Let me type the second equation, the one on the left. W equals to 10x minus 5. So um so they're asking, okay, let's add the slicer. So if I add slicer is this question is actually asking what is the value of w if the question has no solution. So like I explained last time, if the question has no solution, it means that they are parallel. So when w is 1 for equation 1, that means question 1 and 2. If w is 1, that means I put 1 here. Then question 1 and 2 we have one solution, the intercept. If w is 2.3, that this letter is 2.3, they will still intersect one solution. If w is 3, any value of w from here is giving us one solution. Okay, let's see what if w is a negative number. Negative number. You can see negative number. Let's go to minus 3. You can see as I was shifting the w to negative. Let's see w is minus 3 since we have solved this before. So w is minus 3. You can see that the first line, just the blue graph, and the second line, that is the dark line, they are parallel. So at this point, you can see that um, they have one solution. So when w is minus 3, these two equations, we have no solution because they are parallel. So that is what that question is trying to talk about. So let's move on to the next question. Next question here says that if you have 2x plus 3 equal to 7, so I'm going to type this question in Desmos. Let's type in Desmos 2x plus 3y is equals to 7. 10x plus 15y is equals to 35. So the first line is a blue color. You can see the blue color. So the y-intercept was actually 2.3. The second line is a green color. The y-intercept is also 2.3. So this is a case of infinitely many solutions. So that means the two lines are lying on each other. They are lying on each other. So that means more like they are the same. They are the same. Equation 2 is a multiple of equation 1, more like times 5. So they are the same. So that's the case whereby the coefficient of x are the same. So what are they asking us here? They said for each real number r, which of the following point lies on the graph of each question? So r can be any number that I can think of. So what I will do here is that I will type each of the options in the question. So option A, the x coordinate is r over 5 plus 7, while the y coordinate is minus r over 5 plus 35. So let's type it there, and I will set my slicer. So when r divided by 5 plus 7, comma, uh, minus r divided by 5 plus 35. If I set my slicer for this, you can see when my slicer for this r equals to 7.234.5, you can see that I don't have any point that is on the graph. If I change my r to be 2, I have this is not on the graph. it's not on the line. If I change my R to be 4.1, it's also not on the line. So that means option A is wrong. So let's type option B because it has to lie on the graph. The point has to lie on the graph. Let's try option B. Option B is minus 3R over 2 plus 7 over 2, comma R. So for any value of R for option B, you can see when R is 4.1, you can see the point. The answer is minus 2.65 4.1. It's lying on the graph. But they said point lie on the graph. For each value of R, which of the following point lies on the graph. So if R, let's check again. If R is, let me use another slicer, another value of R. If R is 5.6, you can see I have, if R is 5.6 for option B, but I have minus 4.9 of 5.6. It's also lying on the graph. If R is 10, let me check 10. My I will have minus 11.5 and 10. This is also lying on the graph. Do you understand? So if R is if R is 0, you can see this point also lying on the graph. So that is what is actually going on there. So my correct answer is option B. Option B. If I try option C and I type this coordinate for option C, if I type my R this for any value of R which is a real number, the point I'll be getting will not lie on the on the graph. So that's what is going on there. So it's only option B that will make this to lie on the graph. And that explains that. So that's where we are going to end our class for today. So see you in the next class where we are going to explain uh SAT Algebra with Desmos Part 2. Bye for now.